Great. On to the next session here. It looks like we're going to have a Hadoop over Ceph RGW status update. So Jan and Jian, I guess, take it away.
Okay, thanks, Patrick. So this is actually a status update from BP in Infonalis. In Infonalis, we gave some Hadoop solution over Redis Gateway with SSD cache. And since over the past few months, we have some updates here, and we would like to share with you guys. So the content for today's status update is like the first, we are going to recap the design of Hadoop over Redis Gateway with SSD cache. And then we are going to update the status since in Infonalis we actually have 70% of the code ready, and last thing is we have actually did some performance testing with Hadoop over Swift, and we saw some bottlenecks there, and that may be also the bottleneck of Hadoop over Redis Gateway. Okay. So this is a general design of Hadoop over Redis Gateway, BP. So actually there are 3 parts in this proposal. The first one is Redis Gateway FS, which is additional plugin for Hadoop compatible file system. We actually have done 70% of the code there. And the second part is Redis Gateway proxy, which is RESTful service based on Python Whiskey, and it can give out the location of the data based on the object name and container name. And the third part is Redis Gateway with SSD cache. Currently, we are using some vanilla Redis Gateway and the cache tier as the with SSD cache tier as the backend storage. So we actually haven't touched any Redis Gateway code there. Okay, so the general procedure of the Hadoop run is the first thing is scheduler will try to ask the RGW service where the block location, and then Algebra proxy would return the closest active Redis Gateway instance, and then scheduler allocates the tasks on the server that is near to the date, and then tasks will try to access the date from the closest Redis Gateway. Okay, so this is a detailed status update since Infonalis. The first part is Redis Gateway proxy part. We actually have done a small demo based on Python Whiskey module, which accepts some RESTful requests like the curl command here. You can use some query the data location with some RESTful request. And the Redis Gateway would give out the closest Redis proxy would give out the closest Redis Gateway instance based on the container and the object name. Okay, and second part is Redis Gateway file system part. We have 70% of the code down here. It's actually a fork of Swift FS, and with that, Redis Gateway can talk to a single Redis Gateway directory without much modification. But it is only able to talk to single Redis Gateway instance. That actually limits solution scale. So we modified the part of the code, and now with Redis Gateway proxy, and Rados Gateway FS can talk to multiple Rados Gateway instances. We also add some block level location aware read feature in this. And we're going to go through that in the following up slides. And so last part is we have done some baseline performance tests with HDFS and Swift, and there's about 20% performance degradation in Swift side. Okay, this is detailed updates for RGWFS. So in general, there will be a new file system URL with RGW prefix, and with this protocol, we can we can make Hadoop talk to Rados Gateway cluster. Basically, it's a fork of SwiftFS, but there's some modifications on the code, and Rados Gateway is able to talk to multiple Rados Gateway instances, and also we have add some new block concept to RGWFS because in Swift there's actually no block level concept there. So all the get and put would happen at object level. This would make the or the get, read, and the put go through the proxy side, Swift proxy side. So with this new block concept, we actually can do some improvement on the read on the get side. Based on the block location, we can choose which Rados Gateway instance to read from. Basically, we are using some range get API, but however, for the put, we still go through a single Rados Gateway instance since there's no multiple put there. Okay, like I said, we have 70% of the code done there, and there are still some issue on the objects larger than 5 gigabytes. Since if the object is larger than 5 gigabytes, there will be some 0-byte manifest file and lots of small chunks. So we still trying to resolve this issue. But for the objects smaller than 5 gigabytes, this RGWFS is actually working now.
I have a question. Did you disable RGW striping, or how do you know that you access the gateway that is closest to the data? Because with striping, which is by default 4 megabytes, it'll be closer to the data of of the first block maybe, or
Okay.
How do you guarantee that all data is?
Yes. So we actually have done some special configuration in the RGW cluster there, or the strap size has been configured as 64 megabyte. Yeah, like this. So we also increase the max chunk size and to make sure all the chunk size are equal there. So there's we may think there's multiple 64 megabyte blocks there, and then we actually did some hack in RGW proxy side. The first thing is we would use some librados and get XATTR API to get the manifest file that is XATTR from the head object. So you actually know the all the object block names from the manifest file. Like the head object name is actually the object name, and then you know the rest of the blocks, like head object name plus manifest plus -0 -1 -2 -3.
Right. So
this is
for each chunk, you go to a different gateway then.
Yes, exactly.
Right.
So okay. Let me go back. So like just Yehuda just asked, we actually using some range get. So that, for example, the first get for the task for the first Hadoop map is using range get from 0 bytes to 64 megabyte, and the second task is using range get to get 64 megabyte to 128 megabyte. But for the put side, we haven't figured out the right way to do this. Maybe we still need some time to study the multiple upload API there. Maybe this is a potential solution.
Well, for put, if you're using multi-part upload, then the name of the objects, and if you're gonna use a 64 megabytes chunk, then the name of the objects are gonna be named after, it's gonna be the bucket ID, then it's gonna be the name of the objects dot the upload ID dot some kind of running number.
Okay.
So that's gonna be. So, and you have the upload ID because you initiated the upload.
Okay.
But it's only gonna work if you're using multi-part upload, not regular upload.
Yeah, actually, it's not a big problem for the first version, since we actually know the workloads here are very much read-only workload. So there's not much put traffic, I think.
Right.
Okay, so this is RGW proxy part. This is.
Wait a minute. For general purpose Hadoop, it would be a read mostly workload.
I'm sorry, what?
I'm sorry, are you saying that for general purpose Hadoop, it would be a read mostly workload?
Yes. This is part of the. Okay. So for the RGW proxy part, this is a Python Whiskey demo that accepts RESTful requests and give out the closest Redis gateway instance. Actually, we generate a topology file of the cluster, which actually is so. For example, there are 4 OSDs there, and we use some topology file that covers, for example, Redis Gateway is mapping to the first 2 OSD, and the Redis Gateway 2 is mapping to the second 2 OSDs. So this is actually a topology of the entire cluster. And yeah, just like the. So actually, I have said this before. So the first step is Redis Gateway would try to get the manifest from the head object first, using some Python libRedis API with get XCTR, and then Redis proxy would try to use some would follow the crush map and get the location of each block. That is actually a Ceph OSD map command in the cluster. And the last step is RGW proxy would try to go through the topology file and look up which Redis gateway is the closest to the data OSD. So So with this, we can get the closest Redis Gateway instances. Okay, for the third part, RGW, we actually haven't made any modifications on the RGW side. So this is some vanilla version of RGW, except we have done some special configuration there. For example, we use some dedicated chunk size, and also we increased the head object size to make sure all the data are chunked equally there. We use 64 megabyte here, and based on the account container object name, and Redis Gateway could get and put the content there. We actually using range get to get each chunk. And there's a configuration of cache tier there. We actually using some write through mode as a start point to bypass the data consistency issue.
Right.
Okay,
You are aware that when using multi-part upload, the head object size is going to be 0.
Oh yeah, that's a problem. Yeah, this is actually the same issue we met in the objects larger than 5 gigabytes. Since there is also a 0-byte manifest file, and currently we have some solution in RGWFS that is do additional translation between the 0-byte manifest file and the real data chunks. That is, we have to.
It's two different things. You mean that the head file is 0 bytes? Or that the manifest itself has some issues?
Manifest.
Yeah, I'm not sure why that would happen. So
the background is we are actually using Swift API. So for objects larger than 5 gigabyte, we actually follow the Swift way.
I see. I see. So it's using the Swift dynamic large objects.
Yeah, exactly.
I see. Right. Yeah. So for the multi-part upload, you have an issue there. That the first object is just gonna hold the manifest and not anything else. And the rest of the data is going to be at the tail objects. Now, maybe you can tweak RGW for larger than 5 gigabytes objects to just do the same as it does with regular objects. Maybe the regular object upload can work for you for larger than 5 gigs.
Okay, I see. We actually have discussed this solution before, but we thought it might be use some vanilla or upstream Redis Gateway first.
Yeah. Well, you can a change that would make it configurable is probably trivial, so you can make the change and and make it by default 5 gigs, and you can probably get it upstream pretty easy. It
okay.
Should be like a few lines of codes.
Okay, I see. Okay, so this is some results we have done on Hadoop over HDFS versus Hadoop over Swift. There are 3 different deployment considerations. The first one is Hadoop over HDFS. This is a typical setup. And then we have Hadoop over Swift with list endpoint middleware. That is a special configuration for Hadoop over Swift that makes Hadoop can do some local aware read, but for the write, it's actually going through the proxy server anyway. So there's no locality in write side. And the last configuration is we actually disabled the list endpoint middleware. So all the get and put will go through Swift proxy server. That is the original or typical Swift deployment. So on the right side, we have some performance numbers. So as HDFS as the baseline, and we can see list endpoint middleware is impact is huge, and there's about 40% degradation without list endpoint middleware. And we have done some analysis on this, and we found the rename overhead is quite big in Swift side, because in HDFS there's a simple metadata change in name node, that is HDFS rename, and in Swift rename there's some copy and delete process. This is quite heavy, actually. So I guess this will also be an issue for Redis Gateway over Hadoop over Redis Gateway, since we are actually using the Swift API there.
Well, the Redis Gateway itself, when you're doing a copy and the copy is within the same placement target or storage policy, is not actually copying the data. It's adding another reference to the data. So,
oh, that's great.
Mm-hmm.
Okay, so that that is great news.
Mm-hmm. Yeah, so and it doesn't matter whether you're using the Swift frontend or the S3 one. So.
Okay. I will try to dig into that to see the performance for Hadoop over Redis Gateway later.
Mm-hmm.
Okay, so this is next step. So for the development side, we have still 30% left, and I think we can finish the development quite soon. And then we are going to complete the performance test work. That is Hadoop over Redis Gateway with local block level read. I think it's going to be done in July or August. And based on the performance of Swift, we are going to need to resolve the rename issue. But if Yehuda said is okay, then we may need to investigate the copy implementation in Redis Gateway side, and then this might not be an issue for Redis Gateway. And then we actually have code repo on GitHub. Currently it's private, but we're trying to open source the code. I think it's going to be happen very, very soon. So this is the updates from Hadoop over Redis Gateway side. And
yeah,
is there any questions?
Yeah, it'll be interesting to see the performance numbers of the gateway, and whether what kind of bottlenecks you're gonna hit there. Another question that I have is bucket listing something that's you actually need? Listing objects in buckets?
No, we actually don't rely on this feature.
Mm-hmm. So you might find that if you disable, and that you'll need to patch the gateway for that, but if you disable the bucket index writes when you write an object,
Okay.
then it should give you some performance boost for object writes.
Can we do this in Rails Gateway right now?
It's
I mean, disable the bucket.
It'll require code. You need to remove some code there. It's not.
Oh,
It's
okay.
not.
Okay.
It's not just configurable that you.
Okay. I see.
We were discussing that quite a lot. Call it blind buckets, basically buckets that don't hold the index data, and that sounds like a use case for that specific feature. We don't have it implemented, but the path and the code that actually does the bucket index updates is pretty trivial. I think there's not many places in the code that you actually need to change it. It might be something that will make sense to make it configurable. The problem with this specific feature is that certain things are gonna work like multi-site, multi-region, but it's not anything that you're actually interested in. So it might be that you can explore that.
Okay. Okay. I see. But according to our experience, the most potential bottleneck for Hadoop running on Swift, the network is going to be the first bottleneck, because mostly all the objects are quite large, and yeah, the network is.
Yeah, right. So in that case, well, it'll be interesting to see what's the effect. It might be that it wouldn't change anything, and in that case, it wouldn't make sense to do it. But it's something that you can try to explore.
Okay. Okay. I see.
Another thing, and that's something that went in quite recently. There is a way to bump up the number of libRails connections between the gateways and the backend. There's a new configurable to do that. That's another configurable that you can try to look at. I'm not sure actually if you've seen it went into Hammer, probably not. But you can try to look at that change, and it's pretty. It's not very intrusive, and you might want to take a look
Okay.
at that.
So
People reported that they had some performance boost out of that.
okay. So Yehuda, do you mean the number of Rails handlers patch?
Yeah, is it something that you? I don't remember who did it.
Okay.
Did you take a look at that?
Okay, so this is, yeah, it's actually in master only, right? It's not available in Hammer.
Yeah, it's not in Hammer.
Okay. So I guess we need to do some backport work first.
Yep.
Okay. Thank you. I will definitely look into that.
Yeah, it's the RGW num Rados handles. Yeah, I have no more questions.
All right, that about wraps that one up then, or do you have any more, Jan?
That's all.
Okay, great. Thank you very much.